Application performance. This is your business we're talking about. Today, it's the difference between your customer being this guy, who once he's calmed down will promptly go to your competition, or this guy. He likes you. Nice job. Assuring application performance is hard, and it's only getting harder. A modern application today has multiple components, services. You want my business? Whether it's signing up, searching for what I want, posting payments, or selfies, it better work. Every one of these services has a stack, a supply chain of resource providers and consumers that will make or break the performance of your application. That's your customer's experience and their impression of you. So how do you manage it? You don't. You let software do it. Turbonomic is the only platform that continuously assures the performance of your applications while maintaining compliance and minimizing cost. Here's how it controls the performance of a horizontally scalable microservice running in a Kubernetes cluster. This diagram shows a simple Twitter application backed by a Cassandra cluster. We're using Locust to simulate a varying number of users hitting the application. In this example, it's a simple application. You've got a front end, back end, and middle. Each instance of this application service is stateless and horizontally scalable. The state is stored in the Cassandra cluster when a service is running. And the communication between the components is provided by Istio. We're using the Cassandra exporter and Istio mixer to provide the instrumentation through Prometheus for telemetry of both the application and the underlying infrastructure. The components in green are software that Turbonomic provides. Turbo Server is the platform, our analytics, determining what to do and when to do it. Through KubeTurbo, Turbonomic executes those actions, in this case, scaling your application out or back based on demand. PromeTurbo gives Turbonomic application performance information, data, so that it can make the right decisions continuously in real time. All of this is about never violating a level of service. The same information for this application is exposed through a Grafana dashboard, showing the number of requests that are coming into the system, their respective response time, and the number of pods actually serving the application at any point in time. As you see, our Locust user simulator is oscillating between 5 and 300 users of varying requests, tweeting, getting a newsfeed, friending people, much like a typical user would. The whole stack, from the applications all the way down through the pods, containers, and the nodes, as well as the underlying infrastructure that supports it, is managed by Turbonomic. This is the user interface of our platform, where you can navigate all the services that are being exposed with their respective performance and user response time. In this case, the application is running in containers on virtual machines that make up the Kubernetes cluster. If I were to drill into a particular application, I can navigate to the containers only in that project and view the transaction performance, the response time performance, as well as the application and infrastructure resource utilization. But what's most interesting about this is that based on a predefined service level objective specific to each application, Turbonomic is able to make the right resource trade-offs within the infrastructure and applications to decide how many instances of a service, Kubernetes pods, do we need to assure the performance of the application as the user demand fluctuates. None of this requires the application developer or the operations team having to define individual thresholds and manually react to these fluctuations. Imagine what they can do with that time back. Turbonomic is making fully automated decisions to scale down, or when necessary, scale up the application in real time. As you can see, Turbonomic has been controlling this application for several weeks now, while the load has been fluctuating. Back in the Grafana dashboard, we can see that as the user demand decreased, 250 requests dropped down to 16 requests. Turbonomic scaled the number of pods down. Likewise, as the user demand increased, the number of pods were increased. Again, fully automatic without humans having to tweak the applications. The SLOs are continuously met because Turbonomic is making the right decisions at the right time based on application demand. Whether your applications are running in a managed Kubernetes cluster by any of the public cloud providers or running in a cluster on any on-prem virtualized environment or even a bare metal cluster, Turbonomic continuously assures the SLO of every service of your applications. Think about what this means for your customers, for your business, and your teams.